All right, so let's go ahead and get started here. We've got most of the time for doing presentations, but I want to start off by running through homework 8. But any questions before we get into that? Lingering issues on homework 7 or other questions?
Why was the hardest part deleting the certain things in comparison to adding them?
Yeah, deleting is harder than adding, subtracting is harder than addition, division's harder than multiplication. There's information theoretic arguments that can be made with respect to that, depending on how philosophical one wants to get.
Is there a reason, like, programming wise, why it's harder, or is it just that the language is a little more clunky in that area?
I think in a lot of cases, yeah, in a lot of cases I can think of, removing something is going to be slightly trickier. Just because, if you're removing something from the middle, you kind of need to move stuff up. So usually you're either creating a second file and copying it over, or, I don't know, adding, you just kind of glom something on.
Sure.
Deleting, you have to actually preserve the structure that's there, but modify it. I don't know. It's a good question. But it often feels that way to me. All right, so I'm looking forward to hearing homework 7 presentations and seeing what people came up with. But let's talk about homework 8 first, because I'd like you to be able to have time over the weekend to work on this if you like. This is an assignment that I think everybody here can finish in like 2 days of consistent work.
To fix it, I need to.
Yeah, so you have until a week from Monday for this, okay? So it's, 9 or 10 days you have. But I would strongly recommend setting a target date well before that, okay? I would set a target date no later than a week from today, which means that... Yeah, I will in a second, thank you. Set a target date no later than a week from today, which means you have the weekend, you have all of next week to work on this, to ask questions, to bring them to class, to come to office hours. And in absolute worst case, if you don't finish this by 8 a.m. Friday morning, you've still got Friday, you can come to office hours Friday night, and then you've still got the weekend, right? But please don't wait, until the end of next week to start this, because it does take some time, and it's a different type of programming assignment from what we've been doing. And if you start on this, today or tomorrow, I feel like most people could probably finish most of this by the end of the weekend, with one detail that we'll talk about at the very end. So let's run through the basic setup for homework 8. So homework 8 is a phrase index program. It basically reads from standard in and breaks your input into a collection of phrases, what we would think of as, a normal phrase in English. And it builds an index of those and basically records the list of phrases it finds in the input and how many times each phrase occurs. Okay, so it's counting how many times you say, hello there, or how many times you say this is fun, or whatever appears in your input assignment, your input file. All right, you're writing this as a bash script. Let me show you an example of how this might work. So my program's called main, so I can say this is a test. This is a test. Also, it is an exercise. This is fun. This is fun. This is fun. Fun is not run. All right, so there's my input text, and I'm going to hit a Control D to signal end a file, And this will go ahead, it will break my input into phrases, it will clean everything up, make things uppercase, and it will count how many times each phrase occurred. So, this is a test appeared twice, this is fun appeared twice, haha appeared 4 times, also it is an exercise appeared once, and so on. Okay, so the assignment specs out exactly what we mean by a phrase, but basically it's, the beginning of a sentence going up to a period, a comma, colon, semicolon, exclamation mark, question mark, or the end of the line. Okay, this is processed line by line. You read in a line, you break it into phrases, you record a tally of those phrases. And when you get to the end of the input, then you print out a list of each phrase with the number of times it occurred next to it. All right. So in this assignment, I actually describe exactly how to do this. Well, almost exactly how to do this. So let's run through this pretty quickly. So it's a bash script. Okay, reads from standard in, tallies phrases, reports to standard out. Essential requirements: got to run on Linux. You can use sed, you can use awk, you can use tr, you can use any of the built-in stuff available in bash, including for statements for this one, whiles, ifs, doing arithmetic, arrays, associative arrays, which you will definitely want to use, variables, and so on and so forth. Okay, the main functions you'll want to use from outside of this are really sed and tr, and we'll run quickly through tr. We've already used sed a bunch. You probably won't need to use awk, but I put it on the list of allowed functions if you like. There's a big test file up here under /temp called wh.txt. It's the text from Wuthering Heights. It's a 500,000 byte file that your program should not break when you try to run it on that. Alright, so how do you do this? There's a series of steps here. You're going to read a line in from standard in, so you're just going to say read line, right? Once you get that line, convert all the lowercase letters to uppercase. Okay, that's one statement called tr. We'll play with that in a minute. Convert all lowercase letters to uppercase. That's the first piece of cleaning the input. Next, remove any of these characters that you find. Parentheses, brackets, curly brackets, single and double quotes, @ signs. Just strip them out. Alright? This is pretty easy to do if you use tr to change all these characters to an @ sign, and then use sed to get rid of all the @ signs. Right? tr is nice because it doesn't choke on regular expressions, whereas sed understands regular expressions. So if I put in a bracket, it's not going to see that as a bracket. It's going to see it as, part of a regex. So tr can be nice to work with sed. We'll do some examples of that. Alright, so throw away all of these special characters. And then, any spaces or tabs that you find, any collection of them in a row, just change them all into a single space, and then change each space to an underscore. Okay, that's one call to sed also, or one line of sed calls piped into each other. Alright. And then convert any of the phrase separators, period, comma, semicolon, colon, question mark, exclamation mark, just change that into a single space. So after you do these cleansing steps, what you have is an uppercase collection of phrases which are separated by spaces. And the spaces inside a phrase have underscores instead of spaces. So now you just have, phrase 1 space, phrase 2 space, phrase 3 space. Alright, now you need to pull out each of those phrases from this big long input line and do something with it. How do you extract the phrases? You can use a for statement here. So here's a for statement that I am letting you use in bash. This is for variable in big long string separated by spaces. Each time you go through this loop, this variable will be the next thing, the next word, or phrase in our case, from that input. Alright, and what you want to do in here is basically tally that phrase, right? Bump up the count of how many times you've seen it. Alright, so you see a phrase, this is fun. You have to know, have I seen this before? If not, add it to the list of known phrases and say we've seen this once. If you've already seen it 8 times, just bump up that 8 and say, now I've seen it 9 times. Alright, this is absolutely trivial to do if you use associative arrays. Okay, you don't have to do any searching, you don't have to grep, you don't have to do any of this hard work if you use an associative array. We're going to talk about associative arrays in detail on Monday. Okay, there's a little blurb of sample code at the end of this assignment that can get you started on it. But my suggestion would be, over the weekend, if you want to work on this, work on cleaning the input, extracting phrases, and then instead of tallying it, print out in angle brackets, here's my next phrase, right? And just get to the point where you can break your input into nice clean phrases. And then doing the tally part is really like one statement, okay? But we have to talk about associative arrays first. And then once you hit the end of your input, so you're doing a while read variable, right? Once that kicks you out of the while loop because it hit end of file, then you just have to print out your phrases along with the tallies. And that's really just another for loop. This, if your tally was stored in an associative array called count, this will go through each phrase in that index. And if you were to echo $ phrase, you'd see the phrase. And you can use that to access the count that you've collected. All right. And just a note here, before you output the phrase, change the underscores back into spaces so that it looks, like a reasonable phrase. All right. So there's 5 test files available on the Linux server under /temp homework 8 tests. Test 0 through test 4. I suggest you run your program on these. Once you think your program's working, run it against these files, right? Run your program, but just redirect standard in from one of those test files. And then if you want, pipe the output into sort-n, and you can compare it to the output that I got from my sample program, right? So the output that you should get is in test0.out. So run your main program against, say, test0.in, pipe it into sort-n, save that output somewhere, compare it to test0.out from the directory under temp. Make sure it's giving you the same output. Okay, this is part of how I'm going to grade your homework 8. I'm going to run it against all 5 test programs. The 5th one, test4.in, that's Wuthering Heights. That's the big long file. That's the hardest test of all. Right? It's not so much wonky input, it's just a lot of text. Submit a Git repo named homework 8 by the due date. Make sure I'm a reporter, the usual drill there. All right, grading, pretty simplified grading structure. So to receive any points, it's got to be a bash script. It's got to be submitted online properly by the deadline. It's got to run on the Linux server. It's got to work on more than just those 5 test files. So don't just make something that just, outputs those 5 expected results. It's got to be a general solution. Should read from standard in, write to standard out, and can't throw any errors that cause it to exit while it's running. If I run it on and I start typing in phrases and it hits a syntax error and exits, right, then it's hard to grade. So those are your mandatory requirements to get a grade. And then your grade is based as follows. If it's named main, you got 5 points. If it reads input and produces output, you've got another 15 points. So a program named main that just says, what's your name, and says hello, that's worth 20 points. All right, so low-hanging fruit there. Output format should be correct. Number of times phrase appears followed by the phrase, 5 points. No extraneous output. Don't prompt for an input. Don't say hello in the beginning. Don't say here's the results at the end, right? No output except tally phrase, tally phrase, tally phrase, tally phrase. Okay, if you stick to that, you get 10 points, right? And you can see the exact output that should be produced on these test.out files. All right, run it against test 0 through test 3. If it works perfectly, 10 points each. If there's errors with cleansing, if there's errors with not breaking things up into phrases, not tallying correctly, and so on, you lose at least 5 points on each of those tests that it has problems with. All right. Test 4 is a full credit or no credit, 5 points. Okay, if you can produce the exact correct output for test 4, 5 points there. And then 20 points for comments and coding style. So put your name on the top, description of the project in your own words, etc., 10 points. Code indented according to nesting. Comments in the beginning of each section of code saying what you're about to do. Comments on each line that do things that aren't completely obvious, right? That gets you another 10 points. All right. You can read the how to succeed, but let me emphasize this. this assignment is not, you know, hundreds of lines of code. It's not nested loops inside, you know, if statements, inside switch statements, inside this function or that function. It's really just a bunch of Unix commands wrapped inside one big loop that just processes from line to line to line. Okay, so I have a solution of this that's like 23 lines of bash, not counting comments. It's not that it takes, you know, a really sophisticated, you know, deep understanding of, you know, some kind of data structure or something. It's choosing which commands you want to put together and in exactly what way and how to use those commands. Okay, so it's going to be working with sed and tr a lot. And so you want to probably work on this from the command line, right? Take a line of text and start trying to convert it to uppercase, start trying to get rid of special characters, change multiple spaces into an underscore, etc., etc. All right. There's a blurb down here, some sample code for playing with associative arrays. Okay. If you want to, you know, dabble with this over the weekend, you're welcome to, but we're going to go over this in detail on Monday. All right. But if you want to get a head start, you can do that. But if you want to work on this over the weekend, like I say, just work on reading in a line, cleansing it, pre-processing it, breaking it into phrases. All right, that should get you most of the way through. So there's those test files. There's also this main big text, Wuthering Heights, and this is a big file, so 2,100 lines, which are actually paragraphs in most cases, and 663,000 characters. And if you go into /temp homework 8 tests, right, there's test files in there, so here's test1.in. Here's what your program should output if you were to sort the output with sort-n. All right, if you run Wuthering Heights through the input, this is what your output would be. So lots of phrases. And like I say, your program's not going to sort, but if you take the output and you pipe it into sort-n, you'll get output that should be comparable to these test files. All right, so let me just run really quickly through TR, and then we'll hop into presentations. But your main functions are going to be TR and sed. Sed we've already played with. TR is a translation program. And so we can do something like this. TR, you know, A to exclamate A to an @ sign, right? And it basically reads standard in, and anytime it finds this character, replaces it with that character. This will replace any parentheses, brackets, or square brackets with an @ sign. Right, so if I wanted to get rid of parentheses, brackets, and square brackets, I can do this TR, and then I can pipe that into sed, and say get rid of all my @ signs. And now, you know, anything with brackets or parentheses, those just get stripped out. All right, TR will let you specify a range like this. So substitute lowercase a through z with uppercase a through z. All right, so there's your case conversion. So you know how to use sed, you know regular expressions. TR, most of what TR does you can do with sed, but it does a few things more nicely, like, you know, not choking on brackets and parentheses, and so on and so forth. All right. So think about that. Go through your test file and you know. Pick out a line from here. And now you know this would be a line that you would read from your file. Well, you can just go to town playing on this, right? I can echo $sign line. I can pipe it into tr, a through z, right? And there's my case conversion. If I want to change my commas to periods, right, I can run it through sed. And so build up your commands like this, figure out what they do, and once you've got, you know, a series of instructions that do your cleansing, your breaking into phrases, and so on, go ahead and put those in the script. All right, so that's enough to get started. I think people already know enough to do most of this assignment, other than the actual tallying, which we'll dig into on Monday. But I wanted to get that out there so that it's available on the weekend if you want to get an early start on it. All right, so I'm going to turn off my screen share. I'm going to stop recording, and I'm going to turn this over to everyone in class. So, so no, I'm not going to record your